hope this is an interesting talk because the speaker doesn't know what he's talking about. So before I step into this Spark world, I have experience with this MPI high-performance computing. I'm working on some partial differential equations. And then I work on Hadoop, doing some big data pipelines. And now I'm with Spark. I'm helping maintain the machine learning project. So for my understanding is Spark is not just for performance. The best thing about Spark is easy to use and easy to, for developers as well. So think about when you have about terabytes of data, you don't want to do it on a single machine. You worry about your disk space. And maybe you don't want to do it on MPI. You need to deal with the communication. You need to think about how to wrap it into an MPI type. And then maybe you don't want to do it on Hadoop. It's kind of slow for certain type of applications, and it's very hard to set it up. So at Databricks, we try to Spark is very easy. Spark is easy because you only need to worry about your data, what your data looks like, and then how you transform your data into what you want. And at Databricks, we try to make it even easier by just developing standard libraries around Spark. For example, the Spark SQL, GraphX, streaming, and MLlib. That's for machine learning. And we work with the open source community. Like we work with Jeremy Freeman just to develop some streaming machine learning algorithms on MLlib. That's very, very interesting. And for this talk, I want to do a live demo using our product called Databricks Cloud. It's a hosted solution, and you only need a browser to play with your data. And we handle the Spark cluster. We handle everything for you. And let's just get started. This is a browser tab, and I log in. And I mentioned that the speaker doesn't know what he's talking about because this is a neural data set. I got the data set from Jeremy 2 days ago, and now I just want to play with the data set. And it's a Python notebook, so we start loading some Python libraries like NumPy and loading some Spark libraries. And the data set is in the cloud. We can just say sc.txt file. Oh, maybe I should zoom in a little bit. Can you see it? Yeah, OK. So after I enter this line, I load the file in. This is on S3. It's a data set. It's a small data set relative to the neural data sets. It's about just 3 gigs, I think. And now this is called Jiba fish. Actually, I don't know. I have never seen this fish. And yeah, but I have seen its brain many times. Very interesting. And then let's look at it's a text file, so loaded as lines. And I can do this, describe this data set. This is RDD. Remember, RDD is just a data set you can load into memory. And since this is distributed computing, if something goes wrong, Spark knows how to recover it, how to recompute that for you. And I do this lines cache and then count. You just count the number of records, number of lines. It told me, well, it's 2 million records. Well, that's a small data set. And now I can go to the cluster manager and see, well, we have many clusters running. So which one is mine? OK, this one. This is the Spark Web UI. And now this is my data set. You see here, we have 49 partitions. And the data is in memory is about 2 gigs. Now let's go back to our data. Of course, I want to check what the data looks like, right? Maybe it's just each line is a story. Who knows? Oh, they're numbers. OK. So I asked Jeremy, well, how to get the data, what the values are. And well, the first three values for each record are the coordinates. And then the rest of them is time series for each record. So now I try to remember, when you work with Spark, think about the data and the operations you need. Try to chop the operations down to very small steps. And the first step is I want to pass the data set. And I read the parser is a function, basically split by space, and pick out the first two and turn the rest into a series, into a numerical array. And then each record is just 2 parts. Its key is the coordinates, and the value is an array. And now I can do this. Just from the, I didn't do this. So now I have a new data set. That's a mapping from the previous one using this parsing function. And it's a key value pair. Now I can just simply, I didn't import the first. So it's a live demo, that's true. OK. Now I can just do this data.values, just pick out the time series and take the first. You can read, right? You can see it clearly. OK, now, well, what's that? I don't understand. This is too noisy. So maybe, well, let's do some averaging. Because I know the first 2 values are coordinates. And maybe I can just do this averaging of 10 by 10 patches. And the way we do averaging is, let's say, for the top 10 by 10 square on the left corner, I take the average of the points inside. So then I can think about how to express it within the Spark framework. Basically, I want to first do an operation, just divide it by all the coordinate by 10. So you have 5, it becomes 0, 0. And then, then I can do this, the key becomes the new coordinate. And then I can do this reduce by key and take the sum of them, and then do another transformation, try to take the average response of that block. So now we have this, we take the average data, let's run it. OK, now I call this new data set called dataset data 10. And let's check the first. It will do this shuffling. Okay.
Could you quickly show what kind of resources you're using right now? Like how many pieces?
So I'm using a very small cluster. It's a 7-node EC2 cluster. It's running with the M3 2x large instance.
So how much memory is
I think it's 30 gigs. Well, it's big enough to handle this data set. Well, so I think it's running. And this one is good, right? So there's some pattern inside. I know it's something like a periodic, response, but not much. OK. Then this data set is good. Let's use it. Let's cache it in memory. So we don't need to recompute it every time. It's very simple, just called .cache. Now, after this data set has split them into this coordinate and the time series. So they are split into 2 data sets. And with MLlib, we provide some statistic functions such like you can easily check the summary statistics. And for this time series, I want to get all the summary statistics. For example, this one, I want to check the mean. Oh, looks good. I can also just check the variance. I don't know what but I already told you that. I don't know anything about the data set. So I can do this correlation to see whether some time frames are highly correlated. I want to use this rank correlation instead of linear correlation because I don't really know the data, whether the data are around the same scale. So it's a rank correlation, and it's very hard to compute. Basically, for every column, you need to rank them, and then you compute the linear regression, linear correlation between column pairs. So it's very huge computation, but for this, we have clusters, so it's 17 seconds. Let's plot. Oh, that's bad. You have already seen the result. So it's some pattern. Well, at the beginning, we can see maybe there is strong correlation between the first maybe 5 seconds, and then it has certain pattern of that. Now, let's do some clustering. Maybe there are certain patterns we can find out. Just use k-means, train the data set. Remember, the data set is about 2 million records, and now we train with 9 clusters. So it start running, the way Spark is very useful for machine learning, because machine learning usually you need many iterations of your data set. Now I just cache them into memory. Well, it's very easy to just let it run for 100 iterations. It's then 30 seconds. OK, now I want to get the clustering result. It's first, this is the coordinate data set. Remember, I want to zip with A. That's the original data set. Now, for each time series, I want to use the clustering result to predict which cluster it is at. And then I want to collect all of them. Just remember, it's chop down your operation into very small steps, and then just assemble them back. Now, for the clustering result, it's basically we have the coordinates, we have the clustering predicted cluster index. Well, let's check. And, oh, you saw that. Well, that's the result. OK, it's a jibafish brain, but I know there are certain, for example, I know non-terminology here. Well, the yellow one, orange one, I think we call it background. But for others, I don't know. Yeah, but you see, maybe this red one looks interesting, but do you know what region it is? Oh, but well, I think it's fun, but data set, right? So now for each cluster center, well, maybe let's pick out this cluster center and see how it looks. Now this is just a small visualization, and you see here 9 cluster centers. I know the one on the middle right is the background. And then you have seen this different response levels corresponding to those. And I'm not sure whether this is useful or not. This is definitely trivial to do with Spark. And you can just think about how you're going to transform your data and transform them into value. And that's the demo of Spark and the Databricks Cloud. And if you want to find more about, go to Spark website, go to our company website. There's coming a tutorial called AMP Camp, held by Berkeley AMP Camp. That's a good place to start with Spark. That's my demo. And I can just print it out, and this is my slides, and send it to Jeremy. OK, it's a quick demo.